Dear students, in this session, we will discuss about inverted YouTube differential manometer. Generally, this type of manometers are employed to measure very low pressures. If the pressure to be measured is very lesser amount, lesser Pascal, then I will be going for this YouTube inverted YouTube differential manometer. So from the diagram itself, we can see the YouTube is not like this, it is inverted. The YouTube is in the form of inverted U shape is there, and hence the manometer is called as inverted YouTube differential manometer. In the normal manometer, the measuring fluid is mercury, whose density is relatively higher than the other fluids whose pressure to be measured. For example, the density of mercury is 13,600 kg per meter cube, whereas the general fluid is water, whose density is 1000 kg per meter cube. Whereas in case of this inverted YouTube differential manometer, a very good important point I want to share is that the measuring fluid, which is indicated in red color, is not mercury. It should be a fluid whose density should be lesser than the density of the measuring liquid. Here the densities of A and B, both are in this example they given as water. It need not to be water, it can be water, it can be other oil also. But in this case, we are going to take a problem and we are going to explain the physics with the help of a numerical problem, so that we will feel easy to understand the concepts. So we have both as water here. A is also water, B is also water. But if you want, you can take another fluid also. It need not to be water. But the condition is that the density of this measuring fluid, namely which is shown in the red color, should be lighter than the other two fluids. For example, if density is 1000, if density is 800, then the density of this measuring liquid can be, say, some 500 or 600. It should not be more than 1000. I hope you got the concept. So whenever you are going for inverted YouTube manometers, actually you have to use a measuring fluid, namely this indicated in red color, should have a lighter density compared to the other two liquids whose pressure is to be determined. Other than that, the concept almost remains the same. We are going to do a problem. Now this side, the left hand side is also water, the right hand side is also water. Both the containers are not at the same level. This is somewhat below, this is somewhat up. Okay, they are not the same level. It can also be the same level, but in this problem, they are not the same level. When this water is connected to the tube, this water moves against the gravity and tries to compress the lighter liquid So this liquid moves from here to this side, and the other fluid also exerts pressure, whose water column goes up to only this height, namely 10 centimeter, whereas the pressure exerted by the water A is going up to 30 centimeter height. Now, where we have to take the reference section? Here the reference section should be at the maximum top possible. In case of normal manometer, it should be at the maximum bottom possible. Here it should be at the maximum top possible, which means you can see the section XX can be here. XX section can be at this location. Why? It is the maximum top position. In the normal YouTube manometer, what we did, we take the datum at the maximum bottom level. Here we are taking at the maximum top level. Let us give the points as C and D as usual. What are the physics we are going to move? As we are discussing the earlier session for normal differential manometer, YouTube manometer, what are the formula, what is the thing used? We know the pressure C will be equal to what? Pressure D, because they are at the same level. So the pressure should be equal, because they are also having the same fluid. So PC should be equal to what? PD. So the pressure at C should be equal to the pressure at D. Based on this formula, we will try to find the differential pressure between A and B. Either it can be PA minus PB or PB minus A. That is called as what? Differential manometer. But in this problem, they have given the we have to find either PA minus PB or PB minus PA. This is called as what? Differential manometer. This is called as what? Differential manometer. But in this problem, they are given the value of PA also. They are given the value of what? PA also. So what they can ask? They can ask only PB, because PA or PB can be PA minus PB or PB minus PA can be found out. But in this problem, they are given the PA. So they may ask you to find only PB. What is the pressure of the liquid B? What is the pressure of the liquid B? So they are given PA. They are given, this is also given. So we are asked to find only PB. Okay. If PB is negative means the pressure of B is lesser than the pressure of A. If PB is positive means pressure of A is more than pressure of B. That's it. So don't worry about sign. Here in engineering or any physics, the negative sign indicates only the direction. The negative sign indicates only the direction. Okay, fine. Now let us proceed to the problem. Now what is the problem? The pressure at the left hand side limb should be equal to the pressure at the right hand side limb. That is PC should be equal to what? PD. Before that, or we will first write the formula. PA. What is this PA? The pressure of the liquid A plus rho GH. This is the formula generally used to write. What is rho? Rho of the water. G 9.81. H is nothing but what? H1. But instead of here positive, we have to put as negative. Why it is negative? Because the water is going against the gravity. So our datum is not here now. Here it is coming below in case of normal manometer. So that is towards the gravity. So we are using positive sign. Here we have to use a negative sign. Why we are using negative sign? Because the water is trying to move against the gravity. So it is rho A into G into HA. So this is the amount of pressure which will be available at the point C. I will repeat it. It is PA plus rho G H into A. But G is not positive H. G is negative side. So it becomes minus rho A into G into HA. So this is the pressure at what? C. Now let us come to the pressure at D. Now let us come to the pressure at D. Let us start from the right hand side. Let us start from the right hand side and go like this. So what is the pressure at B? It is PB. It is PB plus rho B into G into what? HB. What this? Sorry, is G rho B into G into HB. Here also the water is trying to go against the gravity. So plus G become what? Minus G. I hope you got it. Minus G. Minus with reference to this reference. This also what? Against the gravity. So minus rho of H. This is not mercury. I'm fine. This rho of oil. This is what? Let us take this rho of oil into G is common only into H of oil. Here the oil indicates what? This is what I am calling as oil. This red color mark I am calling as what? Oil. So the formula is very simple. Pressure C should be equal to what? Pressure D. I have taken this data plane as much as top possible. As much as top possible. So this is the maximum possible where the two fluids get differentiated. So coming to the left hand side, this PA plus rho G into HA. But why I put a minus sign? Because G is not positive, G is negative because going against the gravity. Coming to the right hand side, PB minus rho B into what? G into HB of this B water. It's not stopping here only, it's having this side also. So it is rho of oil. This is nothing but oil. G into H of oil. Here also G is negative because against the gravity. With respect to the point D, it is also what? Against the gravity. So if I am going to equate these things, then you will definitely get the value of what? PB. First of all, you should know what is PA. What is PA? 2 meter of mercury. So what is the formula for PA? PA equal to, we know rho G into HA. What is rho? It is 1000. What is G? 9.81. What is H? 2 meter. So it is 2000 into 9.81. I hope it is 19,660. I don't know exactly. I will refer the value. Yeah, it is 19,620. 620 Pascal. So this is the value. So you know this value now. So 19,620 minus, what is rho of A? A is nothing but water. So 1000. What is G? 9.81. What is HA? This height 30. Students used to make a mistake. They will put only 30, but it's wrong because the unit should be in meter. So 30 centimeter will be equal to what? We have to divide 30 centimeter by 100 to convert it into meter. So don't forget to divide by 100. If you are forgetting this one, you will lose more marks. So 30 by 100 will give me my height in meters, which is equal to PB. I don't know. That only I am going to find out. Minus, what is rho B? That is also water only. If this is another fluid means you have to substitute the density. That's it. So it is 1000 into 9.81 into HB. Once again, don't put 10 alone. 10 centimeter. So convert it to meter divided by 100. Minus, what is rho of oil? Specific gravity is given as 0.8. So density will be equal to what? 800. because we know specific gravity equal to what? Density of fluid by density of water. So it is 0.8 into 1000 will be equal to density of the fluid or density of the oil here. So it will be 800. So the density of oil is what? 800 into 9.81 into head of oil. What is the head? 12 centimeter. So don't forget to divide by 100. So now this equation have how many variables? Only one variable. All others are numbers. You can calculate. From this you can find the value of PB. From this you can find the value of what? PB. This coming around is coming around 17,716.86 Pascal. Okay. So if you feel that number is a little higher, means you can divide by 1000 and you can tell us what? 17.716 kilopascal. But it's enough to tell in Pascal itself, nothing wrong in that. So I hope it is very clear. You will be able to enjoy the usage of the inverted U-tube manometer. We have explained the concept with the help of a numeral, and we have seen the approach is same. The only difference between the normal manometer and this inverted U-tube manometer is that the machine should liquid should be a lighter liquid than the other two liquids whose density is to be, whose pressure is to be determined, and we have to take the datum height at the maximum top possible. That's the second point. The third point is become negative because G will not be positive, G will be acting against the gravity. I hope it is very simple. And in the exam, instead of water and water, they can ask water, and instead of this water, they can give a density of 1100, 1200, something like that. Okay, so don't worry, it should be always water. It can be water or any other liquid also. If you know the approach, then the problem is nothing. I hope it is clear. Thank you.